This video is on fractions, and by the end of this video, you should be able to better understand what fractions represent, and you should also be able to add, subtract, multiply, and divide fractions. Okay, so first of all, what do fractions represent? Let's say we have a fraction like 3/5. What that means is you have 3/5 of some whole. So I will draw a rectangle that represents my whole. I prefer rectangles over the circles. Um, and that whole is divided up into 5 equal parts. Okay? The number of parts of equal parts, the whole, is divided into. Okay, so the whole is divided up into fifths, and of those parts, I have 3 of them. So I have 1, 2, 3. Number of parts. Okay, so this is the way 3/5 is drawn, and because I have 3 1/5 pieces, or 3/5. Okay, now the question becomes, what does it mean when I take 3/5 and I add to it, let's say 1/5? Okay, well, I already have 3/5, and if I add one more fifth, then I have this one, which means in total I have 1, 2, 3, 4 fifths. Okay, now the typical rule or algorithm, as it's called, that we use is where you add the numerators together, the top numbers, and you leave the denominator the same. And the reason is because the numerator tells you how many parts you have. And so it makes sense for us to add those together. Now the denominator tells us how big that piece is. And so it doesn't make sense for us to add the denominator because it tells us how big the piece is. So you add the numerators and leave the denominator the same. Okay. Similarly, if we were subtracting, instead of adding but subtracting 1/5, that means that I have 3/5 and I take one of my fifths away. Take one away. Then how many fifths do I have? I have 2/5. Okay, again, we subtract the numerators because that tells us how many pieces we have, and we leave the denominator the same because that tells us the size of the piece. Okay, that works as long as we have the same denominator. Okay, but let's say instead of adding 1/5, we add something like 3/10. Okay, now the size of the pieces are not the same. Let me draw 3/10. So I have the whole, the same whole, divided up into 10 pieces. And of those 10 pieces, I have 3 of them. Okay, now I want to add these together, but it gets a little complicated because the size of my piece is not the same. So what I'll need to do is to change my fifths into tenths, or to find some way of making the same size of piece. So if I cut my fifths each in half, so now that I have tenths, I have, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. Okay, now the typical rule that we use is to find a common denominator. And we do that by multiplying top and bottom of one or both fractions by some number that would give us a common denominator. Okay, in this case, that denominator was 10. And so what I would do is multiply top and bottom by 2, because 5 times 2 makes 10. And I would get 6 over 10, which happens to be what this picture is of, 6/10, plus 3/10 gives us 9/10. Okay, so finding a common denominator. Let me give you one example without pictures. Let's take 4/7 plus 3/5. Okay, now the common denominator we could use is 35. There's nothing smaller than 7 times 5 that would give us a common denominator. So I'll multiply top and bottom of this fraction by 5, and top and bottom of this fraction by 7, because 5 times 7 gives us 35. Okay, now we have the same size of piece that we're working with, and the numerator, 5 times 4 is 20, and 3 times 7 is 21, and so 20 plus 21 is 41 over 35. Okay, now this is an improper fraction, but that's okay with me, and most mathematicians, as you move up in math, are okay with improper fractions as answers. So 41/35 is fine. Again, that means I have 41 pieces where each piece is size 1/35 of the whole. Okay, let's move on to multiplying. And let's talk briefly about what multiplying, what that means. So if I have, for example, 4 times 5, what that means is I have 4 groups of size 5. So I'll use little circles. So I have 1, 2, 3, 4, 5. That's one group. 1, 2, 3, 4, 5. Two groups. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 4 groups of size 5. Okay, so how many things do I have in all? Well, I have 20. If I counted them all, I'd get 20. Now, perhaps an easier way to draw this is by using some boxes. Okay, and that gives me 20 little squares. Okay, so I have 4 groups of size 5. Let's take that idea into fractions. If I have, let's keep our 3/5 and multiply it times 1/2. Okay, so I will again redraw 3/5. Okay, now I have 3/5 groups of 1/2, and so I will cut each of these pieces in half and take half of them. So if I take this one, half, and this one, and this one. Okay, and I'm looking at just the blue parts. I have 3 of them, and how many pieces of that size make up the whole? Well, there's 10 of them. So I have 3/10 is what 5/3 times 1/2 is. Now, the typical rule or algorithm that we use is where you multiply the numerators together, 3 times 1, and that works here, and 5 times 2 gives us 10. Okay, so typically we multiply the numerators, multiply the denominators, reduce if necessary, but that's the way you multiply fractions. Let me give you one more example. If we have 9/7 times, let's say 2/3, I multiply those together. Top 9 times 2 is 18. The bottom is 7 times 3, which is 21. Now there's a common multiple in both these. They both go into the number 3. And so if I divide 18 by 3, I get 6. 21 divided by 3 is 7. And so my answer is 6/7. Okay? You should get in the habit of always reducing your fractions because it's simpler that way. Okay. Now let's move into division. Okay? And division gets a little more complicated. Okay? Let's move kind of into what division means. We have 8 divided by 2, for example. Okay? What that means is how many groups of size 2 are there in 8? So I have 8 things. How many groups of size 2 are there? Well, if I take this group of 2, and this group of 2, and this group of 2, and this group of 2, I have 4 groups of size 2. Okay, 4 groups of size 2. Now, I think a lot of you could have said, well, yeah, the answer is 4. That's pretty easy. Now, the important thing, especially when we move into fractions, is that we have just redefined the whole. Okay, before our whole was one circle. But now as we're getting to these into the answer of a division problem, the answer is 4 groups of size 2. So 2 becomes our new whole. Okay? So it gets a little tricky because it changes how big the whole is. Let's move into a fraction problem. If I take, let's say, 3/4 and divide it by 1/2. Okay? Let me first draw what 3/4 is. Okay, there's 3/4. Now the question is, how many groups of size 1/2 are there in 3/4? Okay, so what I'll do is I will cut each of these in half. Okay, and I will count how many pieces I have. I have 1, 2, 3, 4, 5, 6. Okay, and the denominator, although you want to say it's 8, because that's what the picture says to us, at least in our past discussion. But we just redefined the whole to be halves. Okay, so let's look at this again. This is half of the whole, and this is half of the whole. Okay, so our whole is not made up of 8 pieces, it's made up of 4 pieces. Okay, so I have 6 pieces, and the whole is 4 because I'm looking at halves. Okay, now this simplifies down to 3 halves, but that's kind of what the division means. Now, if you're totally lost, I wouldn't be concerned. Let me show you the algorithm or the rule that we typically use, and that I think will be easier for you if you're lost. Let me do the same problem again, except using the typical rule that we use. So take 3/4, and instead of dividing, which can be a little tricky, what most teachers teach is to flip and multiply, or invert and multiply, or there may be some more sayings, but you make it multiplication, and you take the second fraction and you flip it over or take the reciprocal. Okay, which now becomes a multiplication problem, and we just talked about how you multiply. You multiply the numerators together and get 6, and multiply the denominators and get 4, and we simplify down to 3 halves. We kind of just throw in right here the fact that you could simplify here if you wanted to. Now, if that makes sense to you, go ahead and do it. It would save you a step in simplifying later. Okay, now I hope this has helped. We've talked about fractions. We've talked about what they represent. We've talked about how to add, subtract, multiply, and divide them. And I hope putting that in a context will help you.